Is ocean acidification a widespread global problem? Have you ever wondered how the oceans are reacting to climate change? One major concern is ocean acidification, and it is indeed a widespread global problem. This issue is especially noticeable in the polar regions, such as the Arctic and Southern Oceans. Ocean acidification occurs when the ocean absorbs excess carbon dioxide from the atmosphere. This carbon dioxide reacts with seawater, forming carbonic acid, which lowers the pH of the water and makes it more acidic. This chemical change reduces the concentration of carbonate ions, which are vital for marine organisms like plankton, shellfish, and corals to build their shells and skeletons. The polar oceans are particularly at risk for several reasons. Cold water absorbs carbon dioxide more effectively than warmer water, making areas like the Arctic Ocean more susceptible to rapid acidification. The Arctic Ocean is acidifying at a pace that exceeds the global average. Some of the fastest rates of acidification are being observed here due to its naturally low buffering capacity and cold temperatures. Additionally, complex circulation patterns in the Arctic can concentrate carbon dioxide in certain water masses, further accelerating the problem. Melting sea ice and freshwater input from rivers and thawing permafrost also contribute to this issue. They reduce salinity and alkalinity in polar waters, which speeds up the decline in pH and increases the corrosiveness of the water. In the Arctic, other sources of acidification include the decomposition of organic matter from thawing subsea permafrost and the oxidation of methane. These processes can raise carbon dioxide levels beyond what is found in the atmosphere. The consequences of ocean acidification in polar regions are serious. A reduced availability of carbonate ions makes it harder for key species, such as plankton and bivalves, to form their shells. This threatens their survival and can disrupt marine food webs. Plankton, which contribute about half of Earth's oxygen production, are particularly affected. This disruption can have cascading effects on broader marine ecosystems. Moreover, acidification impacts not only the Arctic Ocean but also downstream ecosystems, like those in the North Atlantic. These ecosystems relying on Arctic outflows and support important fisheries. Changes in ocean chemistry can alter species composition and productivity, leading to unknown long-term effects on biodiversity and the livelihoods of communities that depend on marine resources. To address this issue, monitoring efforts in polar regions are crucial. Scientists use advanced tools like computational models and long-term chemical observations to track acidification trends and understand spatial variability. These efforts are essential for informing policy and conservation strategies aimed at mitigating impacts. In summary, ocean acidification is a global issue that is intensified in polar regions due to their unique environmental conditions. The rapid acidification observed in these areas poses risks to marine ecosystems and the services they provide. Continued monitoring and research are vital to address this pressing problem.